Hey guys, this is Megan again from OnlineMathCircle AIME video tutorials. Today we are going to look at 2009 AIME I problem number 8. Let S equal the set 2 to the 0, 2 to the 1, 2 to the second, all the way to 2 to the 10th. Consider all possible positive differences of pairs of elements of S. Let n be the sum of all of these differences. Find the remainder when n is divided by 1000. So, looking at the sum of all the possible differences between pairs of elements of S, we have n equal to 2 to the 1 minus 2 to the 0 plus 2 to the second minus 2 to the 0 plus 2 to the third minus 2 to the 0, and so on, all the way to 2 to the 10th minus 2 to the 9th. So, looking at the total number of times that each of the elements of S appears in this sum, we can see here that 2 to the 10th appears 10 times. Similarly, by symmetry, since there is an odd number of elements in set S, we have 2 to the 0th power appearing 10 times as well, except that it's being subtracted. So we put a negative sign here. 2 to the 9th appears 8 times. Then by symmetry, negative 2 to the 1st also appears 8 times. 2 to the 8th appears 6 times. Then by symmetry, minus 2 to the 2nd also appears 6 times. 2 to the 7th appears 4 times. So by symmetry, minus 2 to the 3rd also appears 4 times. 2 to the 6th appears 2 times. So that means minus 2 to the 4th also appears 2 times. And that leaves us with 2 to the 5th appearing 0 times, because the number of times that it's being added is equal to the number of times that it's being subtracted. So, to write n in a more simplified manner, we have n equal to 10 times the quantity 2 to the 10th minus 2 to the 0th, plus 8 times the quantity 2 to the 9th minus 2 to the 1st, plus 6 times the quantity 2 to the 8th minus 2 to the 2nd, plus 4 times the quantity 2 to the 7th minus 2 to the 3rd, plus 2 times the quantity 2 to the 6th minus 2 to the 4th. And furthering this computation gives us 10 times 512 minus 1 plus so furthering this down gives us 10 times 1023 plus 8 times 510 plus 6 times 256 minus 4, which is 252, plus 4 times 128 minus 8, which is 120, plus 2 times 64 minus 16, which is 48. Now, we have to find the remainder when n is divided by 1000. In other words, we have to find the value of n in modulo 1000. So this value of n is congruent to, in mod 1000, 10 times 23, since 1023 is congruent to 23 mod 1000, plus 80, since 510 times 8 is 4080, so that's congruent to 80 mod 1000, plus, and 252 times 6 is 1512, so that's congruent to 512 mod 1000, plus 4 times 120 is 480, so that's 480, plus 2 times 48, which is 96, so that's 96. And now, adding all these together, we have 230 plus 80 plus 512 plus 480 plus 96. And when we sum all of that together, we get 822 plus 576. And adding all of that together gives us 1398, and that is congruent to 398 mod 1000, leaving 398 as our final answer.